Our abstract research on household waste material for soundproofing application revealed that various materials such as board paper, cutting board, cotton fabric, polystyrene, and wood can effectively reduce noise level. The effectiveness of this material depends on factors like material thickness, density, frequency, and distance between sound source and material. The study found that polystyrene and wood were the most effective soundproofing material due to their ability to absorb sound waves. Other materials also reduced sound transmission to some extent, but were not as effective. For introduction, soundproofing is an important consideration for many households, particularly those located in noisy urban environments. Traditional soundproofing material, such as fiberglass insulation, can be expensive and have negative environmental impact. Therefore, there is a growing interest in using sustainable materials for soundproofing application. This project investigates the effectiveness of household waste material for the soundproofing application. The research methodology involved testing each material's sound transmission loss. The research population include a sample of 8 household waste material, which is sponge, board, cutting board, fabric in cotton, polystyrene, paper, pen, and wood that commonly found in our environment. The expected outcomes of the research project are to identify the most effective household waste material for soundproofing and to provide recommendations for sustainable soundproofing solution. In our experiment, we have two objectives, which is to evaluate transmission loss of material, second, to find relationship transmission loss and frequency. Next problem statement. To predict the best sound absorber from household waste material by analyzing their physical properties. Household waste is cheaper and suitable for the soundproofing application due to the dense nature. Its dense nature effectively block noise, make it ideal for our purpose. In this experiment, we have five methodology, which is to illustrate the model, prepare the sample, next set up the model, testing various material, and the last one is analyzing result. Now we go through one by one for methodology. First, illustrate the model. We provide a research model that will be used to record the sound level on the source side of a barrier L1 and the sound level on the receiving side of a barrier L2. I share a few different materials for sound absorption and their effectiveness at different frequency. This can assist in explain how sound waves are absorbed and how various materials can be used to increase sound insulation. Second, prepare the sample or material. The material used for the sound absorption testing include cardboard, sponge paper, board, cutting board, polystyrene, fabric, pen, and wood. These materials are affordable, readily available, and effective at absorbing sound waves. Each material has unique properties that make it effective for different applications. By carefully selecting and preparing a sample, you can ensure that the results are accurate and reliable. Next is set up the model. We measure the transmission loss of various materials by using two-tube method. The sample was placed in the center of the tube. One tube contained a sound source and handphone that linked with the sound meter apps to find transmission loss L1, while the other tube contained a handphone that connected with the sound meter apps to find the transmission loss L2. The method allows us to accurately measure the soundproof of different materials and determine which material was the most effective at absorbing sound. After that, testing various samples. All the samples were tested one by fixing the frequency from 100 Hz to 600 Hz, and all of the data was recorded in table L1, sound level on the source side of a barrier, and L2, sound level on the receiving side of a barrier. And the last one is analyzing result. Based on the data we have collected, we can calculate the transmission loss using the equation TL equal to the L1 minus L2, where the L1 is the sound level on the source side of a barrier measured in decibel dB, and L2 is the sound level on the receiving side of a barrier measured in decibel dB. By calculating the transmission loss of each household waste material, we can determine which material are the most effective at reducing sound transmission. In practical terms, a high TR value indicates a greater reduction in sound level and better soundproofing performance.
Okay, next is about literature review. Previous research has shown sustainable products and how they can ensure the availability of resources for future generation without causing negative environmental effect, waste, or contamination. For example, a study by Francesco Asrubali 2006 for a paper explore new noise control material that have been developed as an alternative to traditional material such as glass or rock wool. The study highlight various approaches used to assess sustainability such as LCA, carbon, and eco-profile. The paper provides an updated review of the acoustical characteristic, sound absorption coefficient, and sound insulation statistic of sustainable material, as well as an analysis of their sustainability practices. The study concludes that acoustical sustainable materials such as those obtained from natural or recycled materials provide an affordable alternative to traditional synthetic material. These materials are lightweight, environmentally spinning, and have good sound and thermal insulation. However, further characterization and a consistent process for assessing sustainability are required. A study analyzed the transmission loss of eight materials in a tube with speakers, finding wood and polystyrene as the most effective soundproofing materials. Fabric, pen, and cutting board material had lower transmission loss. The study found that transmission loss was dependent on sound wave frequency with resonance inconsistencies. To reduce error, measurement should be taken at the right time. Equipment calibration should be done and the experimental design adjusted to minimize irrelevant variables. Okay, that's all. The next slide is about findings. Okay, based on the graph, the most effective materials were found to be wood and polystyrene. These materials were effective at absorbing sound and reducing noise levels. The higher the sound transmission loss, the better the material absorbs sound.
In conclusion, the research conducted in this investigation has shown that household waste material can be effective for soundproofing application. The most effective material were found to be a wood and polystyrene. These materials were effective at absorbing sound and reducing noise level. The higher the sound transmission loss, the better material absorbs sound. There are many benefits to using household waste material for soundproofing applications. Not only are they effective at reducing noise, but they are environmentally friendly and cost effective.